The Centennial Bridge spans the Mississippi River, connecting Davenport, Iowa, and Rock Island, Illinois. Maintenance for the bridge is jointly funded by the Iowa and Illinois Departments of Transportation. When cracks were identified in the expansion bearing rollers for the arch spans, the Illinois DOT turned to WHKS and Company. The project presented significant challenges, requiring a bearing replacement procedure using custom-designed bearings in a jacking system, while limiting disruption to traffic and minimizing modifications to the bridge's historical, aesthetic, and cultural value. The WHKS team demonstrated how great things happen when engineers think outside the box. Their innovative approach returned proper performance and operational safety to the bridge's tight arch span and earned this year's ACEC of Iowa Engineering Excellence Award for Transportation Projects. Original construction of the Centennial Bridge began in 1938 and was completed in 1940. Structures designed during this time period often lacked consideration of future maintenance needs. As a result, modern repair and rehabilitation efforts for these historic structures can be complicated and frequently require unconventional repair methods and construction techniques. Existing expansion bearings for the tight arch spans of the Centennial Bridge accommodated lateral movement with a series of nested rollers. The original bearings also included a hinge near the top of the upper portion of the assembly to accommodate span rotation. An initial field inspection determined that corrosion likely impeded movement and led to the cracks on the rollers. Yet, the bearing components immediately above and below the cracked rollers were in good condition. The simplest solution initially seemed to be a bearing replacement with a commonly available modern bearing type, such as pot or disc bearings. Yet, WHKS engineers were concerned that using commonly available bearings would introduce two hinge points. The existing hinge and rotation accommodated by the elastic pad, which could lead to stability and alignment issues. The best solution, it was determined, was a customized replacement bearing and jacking system that would fit and work within the confined space of the original rollers. This approach maximized the use of existing bridge components, minimized the need to address corrosion and costly structural strengthening applications, while limiting the overall impact of the structure's appearance. The replacement bearing was designed and detailed to allow only horizontal translation associated with the span's thermal expansion and contraction. The design featured a stainless steel and lubricated PTFE sliding surface, components often used in common bridge bearings. The large dead load reaction and the fact that the structure was not originally designed to accommodate a jacking system for bearing replacement presented a complex problem. The replacement procedure also temporarily reduced the structure's capacity to resist lateral wind loads. Constant coordination was required between the design of the replacement bearing and jacking system to ensure both would fit within the available space and allow the contractor to perform the replacement with a narrow time frame, quickly restoring the full lateral wind capacity. After designing the replacement bearings, the WHKS team evaluated the remaining space available for a row of jacks on each side of the proposed bearings. The behavior of the upper bearing assembly, with its complex shape and stress state, is difficult to accurately predict with conventional analysis methods. Therefore, advanced finite element modeling was integrated to help predict stress redistributions in the upper portion of the existing bearings. Keeping the bridge open during the bearing replacement provided significant economic benefits. It ensured continuous community connectivity, eliminated adverse travel costs associated with a full bridge closure and detours, and minimized potential economic losses from diverting traffic away from the area. This project exemplifies engineering excellence with innovative, cost-effective solutions, minimal structural modifications, and limited inconvenience and service disruption to the traveling public. Congratulations to the Iowa and Illinois Departments of Transportation and WHKS and Company for a complex job well done.